Okay, example 6. Again, we have an inequality that has a fraction in it. First thing that we need to do is make sure that there is a 0 on the other side. We have a 1, so we need to move this 1 to the other side. Since it's a positive 1, we are going to subtract that 1 to the other side. So I'm going to write my fraction, and then just write -1. And then write my equality sign back and put the 0. Okay, once we have that inequality sign, we are able to box our function. So this is our function right here, my f of x, and we need to determine whether it's positive or negative. So here, this is going to be less than or equal to 0, so that is going to be negative. So that means we are only going to take our negative values. Once you've established whether it's negative or positive, you are able to change this inequality sign to a plus sign. Sorry, not a plus sign, an equal sign. And then we can solve from there. Again, if you go back to 3.4, right? Yep. Section 3.4, we talked about how to solve fractions with equal signs. We had like a 4 or 5 step process or something like that. Let's kind of run through that right now. Essentially, the first thing you want to do is make sure that everything is a fraction. So that means this 1 needs to be over 1, and this 0 would have to be over 1, right? We need to factor if possible, and then use parentheses around our parts. Remember, pluses and minuses separate your parts. So we have parts on the top here. On the bottom, pluses and minuses separate your parts. We have 2 parts. They both share a 2, so I'm going to factor that out. And then over here, we're good. And over here, we're good, okay? And then our goal is to have the exact same denominators. Y'all remember that? So we have a 2 here and an x minus 2 here, and then we have 1s here. So essentially, if you do it to the top, you also need to do it to the bottom. So this one's missing a 2 and an x minus 2 on top and bottom. And the bottom over here is also missing a 2 and an x minus 2. So if you do it on the bottom, you also have to do it on the top. If you want, I don't know, some people like really for it to look exactly the same, you can multiply by the 1. It doesn't matter, okay? So our bottoms are now all exactly the same. And before you cross out the bottom, you need to see what x cannot equal. So before you cross this out, we look inside of our parentheses, or if there's like an x or something on the outside, and we see what would make it 0. So here, x cannot equal positive 2, okay? So we need to add this as our critical value, and because it's not equal to, we're going to use parentheses, okay? And now we can cross out the bottom, okay? So to get rid of parentheses, first you check the power, then you distribute. If you distribute that 1, those signs are just going to drop, or parentheses rather. Okay, over here we have, don't forget the sign. We always take the sign, okay? So we have negative 1 times 2, which is just negative 2, right? So we are going to take this negative 2, so we always take the sign, and distribute it to both of our parts. So if we take negative 2 to both of these, we get negative 2x and positive 4 equal to 0. 0 times anything is always going to give you 0, right? So we look at this, it's a simple algebraic equation. Our x's are raised to the same power, so we do not want it set equal to 0. We want to get the x's by themselves. So we can combine like terms. We have x and negative 2x. So if we were to combine that, x and negative 2x, that is going to give us negative 1x, right? And then if we combine positive 1 and positive 4, because we always take the sign, we are going to get positive 5. And that's equal to 0. Okay, so now we subtract our 5 on both sides, and we get negative x is equal to negative 5. Our goal is to get the x by itself. Remember, whenever you have your negative connect to the x, you change the sign of all of your parts. In this case, we have one part on the left and one part on the right, so this will become a positive, and this will become a positive as well, okay? So this is now one of our critical values. Remember, we need to look at our inequality sign to determine whether this is going to be with parentheses or brackets. We go back up to our original equation, or inequality. There's a line here, and a line means brackets, okay? So when we're graphing this one, our 5 is going to be with brackets, and our 2 is going to be with parentheses, okay? So I am going to write down some of this information on my second board so we can kind of finish this problem out. Okay. So we found our critical values of 2 and 5. It cannot equal 2, so we use parentheses, and it can be 5, so we use brackets, okay? We know that our box is negative because it's less than, so we are only going to take our negative values once we graph it. We're going to use way 2 in this case because we have a fraction. And remember, you do not take this original equation. You only take where the box is located when you're plugging in. You always plug into the box, okay? So I'm going to write our numbers on there. We have 2 and 5. And just like I said, we plug into the box, okay? So easiest number over here would be 0. We could do 3. And we could do 6. And we plug these into the box, not the original inequality, okay? So when I take 0 and I plug this in, we get 0 plus 1, which gives us a 1 on the top. We put 0 on the bottom, and we get negative 4, okay? So we have a negative minus a negative, which is going to give us more negative. So we have negative. And we have our 3. So we have a 4, 6. We have a positive. Yeah, okay, so that's going to give us a positive. Again, remember, you can plug in your calculator and do the answer thing, but if not, you can just do it by hand. 3 plus 1, 4 over 3, 6. 6 minus this would give us a 2. 4 over 2 is the same thing as 2 minus 1 gives us a positive 1, okay? If you want to do it by hand, you can, but you can always utilize what you have. We can plug in our 6 here. We get 7. And then on the bottom, we get 6, 12. 12 minus 4 gives us an 8. This number is smaller than 1, and now we're subtracting 1, so we're going to get a negative here, okay? All right, and we only want the negative values, intervals, so we're going from here to here, and from here to here, okay? So when we write this in interval notation, we start with our negative infinity, we go to 2, we have our union, we have our 5, and we have our infinity. Remember, your infinities always have parentheses. Our 2 has to be with parentheses because we cannot include it, and our 5 has to be with brackets because of our inequality sign. And this would be our final answer.